We'll run through an entanglement distribution example that utilizes these 3 repeater steps on Alice and Bob's network. We will be assuming that all of our probabilistic processes work on the first try in this example, otherwise this example could get a little bit too complex and lengthy. Our goal in this example is to distribute entanglement between Alice and Bob. The first thing we're going to do is perform EEG to get distributed entanglement between each pair of neighboring nodes. After running our EEG protocol for each pair of neighboring nodes, we'll have entanglement between Alice and repeater 1, between repeater 1 and repeater 2, and so on. We need to distribute entanglement between neighboring nodes before we can do entanglement swapping. Note that we might want to do multiple elementary entanglement generations between each pair of neighboring nodes so that we can perform entanglement purification. For example, we could perform elementary entanglement generation multiple times between Alice and repeater 1, and then use those multiple entangled pairs to create one higher quality entangled pair between Alice and repeater 1. When we go through the rest of this example, remember that we might want to do things multiple times in order to be able to purify our entanglement and ensure fidelity stays high enough so that Alice and Bob can actually make use of the distributed entanglement. We would also want to do this whole entanglement distribution process that's going to be shown in this example many times because Alice and Bob will want to use more than just one shared entangled pair. Now that we have entanglement between each pair of neighboring nodes, we're ready to do entanglement swapping. Here we'll perform a swap at repeater 1 to extend our entanglement from Alice to repeater 1 to Alice and repeater 2, which is closer to Bob. After the swap, we went from entanglement between Alice and repeater 1 and entanglement between repeater 1 and repeater 2 to having entanglement between Alice and repeater 2. Next, we'll perform a swap at repeater 3 to extend our entanglement from repeater 3 and Bob to Bob and repeater 2, which is closer to Alice. It's important to note that we could have done the 2 swaps we mentioned at the same time or in opposite order. After the swap, we went from entanglement between Bob and repeater 3 and entanglement between repeater 3 and repeater 2 to having entanglement between Bob and repeater 2. Now we perform a swap at repeater 2 to extend our entanglement and give us entanglement between Alice and Bob. After the swap, we have entanglement between Alice and Bob, which was our goal in this example. Like we mentioned earlier, we will likely want to do purification throughout this process many times to keep entanglement quality high, and we will also likely want to do this process many times so that Alice and Bob share multiple entangled pairs instead of just one shared entangled pair. This example was relatively simple. In more complicated networks, there will be many paths we can choose between end users instead of just one single path through which we can distribute our entanglement.